Hi, welcome to the second part of our video series on sets. And in this video, we'll be starting with Venn diagrams, and we'll be looking at two set problems. First of all, look at two set problems, problem involving two sets only. And after this, we'll look at three set problems. That's problems involving three sets. All right, so one thing that we need to know is that it's always good that we have good understanding of the different sections of the Venn diagrams and what each section represents. Okay, take for example what we discussed in the last video. This particular point here, particular space here, represent the intersect. All right, as the intersect of the set. Okay, as intersect, and everything here like this represent the A union. Okay, A union B, that's the union of B. Then if you have A complement, this is actually set A. Right, this is set A. Everything here is set A. Right, 1 2 3 4, and A complement will be something that's outside A, that is not part of A, and that's what we have is 5 6 7, which is the shaded part. All right, so we also look at the subtraction in the last in the part one of this video, and you see that this particular one, if you want to do this, this is set A. This particular one is set A. All right, this is A. All right, this particular place is the intersect. All right, so when you do A minus B, so this is A, then you subtract this as if you are cutting out this is the B. You're cutting out everything here, which is B. All right, so what is going to remain is just this. Okay, this is what is going to remain. It's as if this particular one, this particular place, okay, has been cut out. All right, so what you have, like this diagram, you're going to have something like this. All right, that's what you're going to have. While this part, okay, this particular part has been cut out, which is the B. So this is A minus B. This particular place represents the answer when you subtract B from A. All right, so let's look at the two set problem example. A survey carried out on 15 adults shows that 8 of them smoked cigarettes, while 10 of them said they drank beer. Find the number that smoked cigarettes and those that drank beer if each of them did at least one of the two acts. All right, so we have a universal set that says that a survey carried out on 15 adults. So the universal set that we're looking at is 15. All right, so we have number, which on the universal set we're looking at is 15. All right, so then we'll know that 8 of them smoke cigarettes. So let's represent S by all the other that smoke cigarettes, and D by all the other that drank beer. So the number of the adults that smoked cigarettes, which is 6, is 8, and the number of adults that drank beer, they are 10. So that is the information that you need so that you can draw the Venn diagram. Okay, all right, so here we have the total number. So let's say, all right, so what we are saying now is this. Let me just quickly have the diagram now. Okay, so we have let me do it that way, and have other ones like this. Okay, just want to do something that way. Right, I will then use blue. All right, let me just use this one as the intersect. Okay, I'm going to of that. So I'm going to use this one as the intersect of the two. All right, so I have this red one. Okay, I have this red one as this is the one that smokes cigarettes, which is 8. Okay, and all right, so let's just use the color so that I can just use the red here. Okay, so this 8, and I have the one that drank beer, they are 10. All right, so in this case we have 8 people. All right, 8 people that smoked cigarettes, and we have 10 people that drank beer. All right, for us to know, when we say 8 people smoke cigarettes, it includes everything in the intersection. All right, and we have 10 people that drank uh, beer, also include everything here in the intersection, because naturally this D also have a complete circle like this, and the S also have a complete circle like this. So here is a point of intersection. All right, for us to know, if you represent the intersection by X, okay, because we don't know this, so for us to know the number that actually drank the number that actually smokes cigarettes only, how do we do that? We know the number that this particular place. If we don't want to know these people that are here, we need to subtract 8. We want to do, this particular place is going to be 8 minus X, this particular X that is there. So that's how you will know the people that smoke cigarettes only. All right, for us to know the number of people that drank beer only, also it is going to be 10 minus X. All right, so that's what we'll have as that. All right, so now we have the number of people that smoke, the number of adults that smoke cigarettes alone to be this. I will have the number of people that drank beer only to be this. Now, for us to find out, from the question, we are told that we should let's look at it again, so that you'll find the number that smoke cigarettes, okay, and those that drank beer, if each one of them did at least one of the two acts. All right, now, in order for us to know what the value of X is, what do we need to do? We know that the universal set is actually 15. That means everything here summed together is actually 15. So what do we need to do? This 8 minus X plus X here, okay. Then we have plus 10 minus X. Everything is equal to 15. All right, so we have minus X plus X here will cancel out. Then I have 18 minus X, which is 15. All right, so if I have minus X, if I take 18 to this place, it's going to give me 15. Minus 18, and it's going to give me a minus 3 minus X. So I'm going to have X to be 3. All right, so now that I know my X to be 3, so I can easily, do my calculation. This is X is 3 now. Okay, X here is 3. Okay, so here I will just do my 8. Okay, all right, so I just do my 8, then minus 3. So here is going to give me a 5, and here, all right, I just do my 10, then minus 3. It's going to give me 7. All right, so the people, the adults that actually smoked cigarettes without doing any other thing than smoking cigarettes, actually 5. and the number that drank beer without doing any other thing else is 7. All right, so that is how the um, two set problems is being handled. All right, so let us look at other examples involving three set problems. All right, so we are giving example that we have all 50 science students in a college in Ibadan were asked their subject combinations. 8 of the students offered further mathematics, 21 offered chemistry, while 16 offered biology. 7 students offered mathematics and chemistry. That's an intersect. You know that that should be an intersect, right? Mathematics and chemistry, as I said. 8 students offered further maths and biology. That's another intersect. And biology. 9 students offered chemistry and biology. That's another intersect. All right. While 5 students offered the 3 subject combinations. So that means, all right, 3 combination is going to be the middle of all the 3. So that's one of the things that you should know. I would say you should use Venn diagrams to find the number of students that offered further maths but offered neither chemistry nor biology. Okay, then the number of students that offered chemistry but offered neither further maths or biology. The number of students that offered biology but offered neither further maths nor chemistry. And the number of students who did not offer any of the 3 subject combinations. All right, so let's solve this. Okay, so let the universal set um, be all the 50 science students in the college, and we have M for all the science students in the college offering further mathematics. So M stands for further mathematics. Then C for students offering chemistry, and B for students offering biology. Okay, so we just do like this. We know that we have M is equal to 18. Those are the numbers that were given that are offering mathematics. 21 are actually offering chemistry. 16 also 16. We have 16 students offering biology. All right, so we have the number that's 18. We have 18, 21, and 16. Okay, so there's something that you need to know here, that this 21, okay, offering chemistry, including things that are here, things that are here, things that are here. All right, and here. All right, so because we have this particular point, that is mathematics intersecting chemistry. Okay, this particular one, this particular place, chemistry intersecting biology. This particular place is the number of students that offered all the 3 combinations. Okay, so now we have N, that's the number of M intersect C, that is mathematics and chemistry, that is 7, which is there. Okay, we have N, that is mathematics intersect biology, this biology, this particular place. All right, that is 8. We have combination of that number of people that are from chemistry and biology. This chemistry and biology, we have this place as 9. And this place is the 5 that offered all the 3 subjects. Okay, so if we look at the solution for number 1, we have to find the number of students that offered further mathematics. Okay, they're offering further mathematics. That's the number of people that order further mathematics. That is the mathematics. Okay, so but neither chemistry nor biology. Okay, so we have people that are offering mathematics and they are not offering chemistry or biology. Okay, so that means this is mathematics here. Okay, that's mathematics there. This is the place we're talking about. This is mathematics. Okay, now they're offering mathematics, but they are not offering chemistry. Okay, so that means this is out. This place is out, not offering chemistry. Okay, All right, so as I was saying, when we have what we're talking about is that we want to look at the number of students that are offered for the mathematics, but they don't offer chemistry or biology. Don't forget, this is chemistry, this is biology. Right. So what we're talking about here is we're looking at mathematics minus C, that's chemistry minus biology. All right. So we're looking at everything that is here only. This one will go. Right. So this one also will go. Okay. So what we would then need to do is that we know that the number of people that are offering um, mathematics is actually 18. Okay, minus chemistry. All right, don't forget here we already have 2 here. That's the intersect is 2 here. This one is 3. Okay, this one is 5. Okay, we have 4 here. All right, so if you really want to know, if you already know the intersect that are here, 2, 5, 3, I really want to know what is here. So you might not need to go this route if you don't know what's and what is here, but that's the best way to describe that. But you can still say that M only, which is here, that is mathematics only, is also um, M. Can do M minus um, C intersect M, then minus uh, B intersect M, okay, and also minus C intersect M intersect B. Okay, so this B is at the end. So that's exactly what we're doing. So what we then do is that 18 minus C intersect, that is 2. All this intersect is 2 plus 5 plus 3. Then 2 plus 5 plus 3. All right, that is 18 minus 10, that is 8. So that means we have 8 people offering further mathematics only. You can do the same thing for all the rest. This is 254, and you have 21 that are offering chemistry. So for you to find the people that are offering chemistry only, you just need to do 21, which is here. It's 21 here. Then minus 2 plus 5 plus 4. All right, that's with 2 plus 5 plus 4. That is 21 minus 11. So we have 10. So we have 10 here that are offered chemistry only. And for you to find out people that are offered biology only, you can also have 16. That's a 16. Then minus 5 plus 3 plus 4. 5 plus 3 plus 4. That is 16 minus 12. Right, so that's 12. That's again 4. So we have 4 people offering biology only. All right, so you can do that one for everything even before you start doing your calculations on the question that you are given. So once you are done with that, you can easily just do your questions. All right, so that's how we find. So the question 2 started telling us we should find number of people that are actually offering um, chemistry only. That's what you see, chemistry, and they are not offering uh, other than chemistry. Okay. All right. So let us look at the. So how we got the other one is that we have the number of students. That's number 2. Number of students that offered chemistry but offer neither further mathematics nor biology. That means that we are offering chemistry only. We also have number 3, the number of students that offered biology but offer neither further maths nor chemistry. So that's exactly what we did here. So that's how we got our number. Uh, okay, let's quickly look at that. Okay, the number of students that offered biology but offered neither further maths nor chemistry. Right, so they're offering biology, but they're not offering uh, neither further maths or biology. That's the one that we did in the other ones. Okay, so now let us look at other ones. We said the number of students who did not offer any of the three subjects. Okay, the number of students who did not offer any of the three subjects. Okay, now let us look at the number of students that offered all the subjects that we have. So if you look at the number of students that are actually offering all the subjects, so we have 8 here, 8 here plus 2, which is here, plus 5, okay, plus 3, okay, plus 4, plus 10, then plus 4. If you do this, this is plus 10, 15, 18, 22, 32, that's 36. So we have students offering mathematics, chemistry, biology. We have all of them 36, offering all the subjects. They are 36 in number. But don't forget our universal set of all the students, they are 50. So if we were to find the number of students that are not offering any of these three subjects, we just need to do 50 minus 36. Numbers that are offering all the three subjects. We subtract it from the universal set. Alright, then we get 14. So that means in the school, the number of students that are not offering any of the three subjects, they are actually 14. Actually 14. Alright, so let us look at further examples of two set problems as using Venn diagrams. Okay, of 174 students who have studied accountancy, that's the universal set, it was found that 37 students study banking and finance. Okay, 60 study marketing. Okay, so banking and finance, we have 37. We have 60. That is marketing, 60. And we have 111. That is business admin, 111. All right, so that's what we have there. That is the of the universal set of the students, 100% who have studied the accountancy. Okay, so now we have 29 studied banking and finance. Banking and finance. Banking and finance, that is BA. Okay, and business administration. Banking and finance intersects. That is banking and finance BF intersects BA. We have it as 13. Okay, 29. Yes, 29. Then 50 marketing and business admin. Right, marketing intersect business admin. We have 50. Okay, so we have 13 marketing and banking and finance. Then if 45 accountancy students did not register either banking and finance or business admin or marketing, so how many study all the three? How many studied all the three? All right, so that is what we'll quickly look at in that. All right, so let's look at how the Venn diagram is done. Okay, so we have this, like I said, we have 37 banking and finance, uh, marketing 60, business admin 111. So now we have 45 who did not register for any. So that means the people that actually studied banking and finance, business admin and marketing, they actually 174, which is a better set. Then minus 45 who did not register for any of those courses. So we have 129 students that studied the three uh, courses. Okay, so that is one about that. Then for us to have the intersects, we have 13 is all these intersects. We have that one already. So we have uh, Banking and finance and marketing. Banking and finance and marketing, we have 13 here, right? We have banking and finance and business admin. Banking and finance and business admin. Business admin, we have 29. Okay, so we have marketing and business admin. Marketing and business admin, we have 50. Okay, all right. Then let X here. Okay, let X here be the number that study all the three. All right, so if we apply the formula, right, so we're to have that is banking and finance union, union business admin, union marketing, right, under our rule. This union, this, we're going to have number of banking and finance plus number of presumption of mathematics minus all the intersects, then plus the intersect of the others. That's what we're going to have. So that means what we're going to have is that no, this BF union, those are the number of that study all the three subjects. They study at least one on who they are studying banking and finance, they are studying business admin or marketing. Okay, so those are the 129 that we have here. So those 129, they are now equal to that is 111 plus 37. 111 is the people that study banking and finance alone. 37 is the people that have studied this, and number that studied BA, that is 111. I mean, that is 60. All right, so then we then need to minus all the intersects from it. Why are we doing that? Because we already have, let me quickly show you something here. All right, so why we need to do that is that we already have 29, 13, and 30 all inclusive in all these things that we have here. So what we need to do is that because we want to find the X, that's the number that studied all the three subjects, and we're applying the union of all. So this could be what? 111 plus 37 plus 60, then minus all the intersect, then the plus X, which is the one that studied all the three subjects. So when we have the addition together, we're going to have 208 minus 9. So that's 116 plus X. So do the subtraction. So you're going to have X to be 13. All right, so we're going to have X to be 13. That's the total number of students that studied the three courses. What about the number of students who studied both marketing and business admin, but not banking and finance? Okay, so we have the number of students who studied both marketing and banking and finance. That is the intersect of marketing and business admin. Then it's going to be minus, let us look at that, all the intersect. Okay, we're going to have banking and finance. That's people that studied marketing and banking and finance. This is marketing. This is banking and finance. All right, so we look at this marketing, this banking and finance, and don't forget that what we did the other time when we've gotten X to be 13. All right, so this X to be 13 we also need to, for us to know people that actually studied, this particular one and this one only. These 13 that are here study all the three subjects, okay, including banking and finance and all that. So this 13 here study all the three. So for us to get the people that studied this and this one, that this intersect alone, then it's going to be this 50. All right, then minus 13, which is the people that study all the three subjects. So if you do 50 minus 10, that will give 37, and that's the reason why we have that particular intersect to be 13, I mean to 37. That is the M intersect BA. That's what we're looking at. So we need to subtract it from the all the students that study everything. Okay, so in summary, we've been so be able to look at Venn diagrams in solving two set problems and three set problems. All right, and in this last one that we did, were to find the we look at finding the number, how many students study all the three subjects, and in our questions we're given that we have 45 students who did not study any of the uh, courses that I mentioned there. So we have 45 students did not study, so we subtract it from the 174, and that gives us the 129 students that study all the subjects either as individual or as both as combinations. All right, so we also look at how we want to find how many study all the three subjects. And when we talk about three people that study all the three subjects, we're actually looking at this particular point, this intersect of everything. And for you to know the intersect of everything here, okay, the formula for you to be able to get this is actually x, but this particular place plus this and plus this. All right, that is the union of the set. Okay, so we have BF union hem, then union banking and finance. So it means that we have this only. That's number of people that studied uh, banking and finance, or that studied the business admin, or that studied this. Okay, then if you minus this, minus this, minus this, okay, all right, because all those one are the same, then you now add this, it will give you the union of all the sets, and that's what we did here. This, okay, plus this, then minus all here, and because this is the one where this one plus x, which is common, then I had it, which is common for everything. This one is common for all. This one is just common for either two, two intersects. So this one is common for the three. Okay, and we're looking at this, which are not the same. Okay, because we're looking at union. This one, and this one, they are not the same. They are different ones. Okay, so this particular one is intersecting two. This one is intersecting two. This one is intersecting two. I also have this one that is similar for the three. Can either be. So we can just pick one. All right, so that's why we had that, and we got our x to be 13. And because we have this one, this 50 here, intersect the two of them, we can minus the 50 to get this. Okay, so the intersect that is here, which is 29 or thereabout, this particular one, we can also minus the 13. Okay, so for us to get people that study the business admin, that is business finance intersect business admin. All right, so we just need to minus the 13, which study all the three subjects from it. And we also have this one here, which is the 50. That is the 13. That is banking and finance intersect mathematics. This is actually 13. So if you minus the 13 here, so that means there is 0 here. So that means nobody actually studied banking and finance and mathematics. That's what it means. So all the 13 that study all the three subjects, actually none of them studied either banking and finance. Did not study both banking and finance and mathematics together. Okay, so but they study all the three subjects. Okay, so they study all the three subjects, but don't have anyone particularly that studied the banking and finance and mathematics. That we have all of them studying all the three subjects, but we don't have. But here we have people that only study the mathematics and banking and finance together. So that is what um, the is all about. All right, so that is the end of the our video series on the set, and we've been able to look at in summary, we'll be able to look at sets. We said sets is just a collection of things, objects, or numbers. Also, we've been able to see that if all elements of set A are members of set B, then the set A is a subset of set B. And we also said that the set B is then called a superset of A. We'll also look at the set which contains only one element, and we said that is called a unit set, and the set without any element is called an empty set or non-set. All right. We also say that if A intersect B is empty, that's a non-set, then A and B are said to be disjoint. That means they don't have anything in common. All right, so A intersect B, that makes element of X. If X is element of A, X is also the element of B. So that means they have the similar elements. All right, so we have A union B as okay, X is element of A, and we have X is an element of B, or both are the same thing. So we can have X to be element of A, can have X to be element of B, and that is what we did the other time when we have three set problems. You know, we have something like this. So, and when we want to have all the union, so this is A, this is B, this is C. We have this. Okay, first is A. All right, so we have another one here. We have another thing here. Okay, so then we can have all. Okay, which is this one. Okay, or all things that contain for the three of them. So this together with this, together with this, together with this has the union of the set. All right, so I want you to subscribe to our videos on Panel Educate as we bring to you more videos. I want you to find time to ask those questions, and we'll be able to respond to your questions on the set theory. All right, so hope this video has been very informative. Thank you for watching. Bye.